At breakneck speed, this mysterious object is zipping through our galaxy. It's moving at a staggering 1 million miles per hour. That's so fast it might potentially escape the Milky Way altogether. While scientists are trying to understand exactly what this space weirdo is, we're going into space to learn more about it. The object is currently moving at a distance of 400 light-years away from Earth. Let's have a closer look and try to figure out if it could be a runaway probe. Nah, it's way too large for that. The object is around 30,000 times the mass of Earth and 8% of the mass of the Sun. What a giant! Such a size places it in a category that Dr. Darren Baskill, an astronomy lecturer at the University of Sussex, describes as somewhere between a star and a planet. Stars moving at such extreme speeds are super rare. Only 1 or 2 out of every 1,000 local stars travel so incredibly fast. So, if one day you found a star moving as rapidly as our cosmic enigma, you'd see it leave our home Milky Way galaxy in just a few tens of millions of years. In terms of space and cosmic distances, it's a blink of an eye period of time. After all, such stars can live for tens of billions of years. Even though the mysterious object is only moving at 0.001% of the speed of light, it's still potentially fast enough to eventually break free from the gravitational pull of our galaxy and fly into intergalactic space. Let's put this speed into perspective. J1249 is traveling 2.6 times faster than the fastest space probe ever launched. I'm talking about the Parker Solar Probe. The Parker probe reached this speed in June 2024 while looping around the Sun. J1249 was discovered by citizen scientists volunteering for NASA's Backyard Worlds Planet 9 project. These volunteers sift through online images taken by NASA's Wide Field Infrared Explorer and NEOWISE missions. They're looking for anything interesting. 3 of those volunteers spotted a faint, fast-moving object as it moved across WISE images. When they realized what they were looking at, they were incredibly excited, but thought someone had already reported the space object. But surprisingly, that wasn't the case. At the moment, most scientists believe that CWISE J1249 could either be a low-mass star or a brown dwarf. That's a type of star that is larger than a planet but too small to support nuclear fusion in its core, like our Sun does. In other words, such stars don't have enough mass, and their cores can't burn their star fuel, radiating starlight. That's why brown dwarfs, often referred to as failed stars, are smaller and cooler than the Sun. They even have complex planet-like atmospheres, which have clouds and molecules. For example, H2O. Anyway, to confirm or disprove this theory, astronomers continued to observe the object with the help of ground-based telescopes. Soon, they found out that the object had an unusual composition, with much less iron and other metals, compared to typical stars or brown dwarfs. It allowed NASA to claim the unthinkable. J1249 could be one of the oldest stars ever found in our galaxy. Okay, that's certainly a game changer, but why is this potential star moving so fast? The research team has a few theories. For example, the object might be the remains of a binary star system where its companion, a white dwarf, exploded in a supernova after pulling too much material from J1249. Another possibility is that our mysterious traveler may have originated from a cluster of stars that dispersed after coming across 2 black holes. According to experts, one way to get to such extreme speeds is to fall toward an object and miss it. Such gravitational slingshots are how space probes are accelerated to extreme speeds, which allows us to explore the solar system up close over reasonable timescales. The same technique could also explain the speed of J1249. The star could have been born in the crowded center of our galaxy. Then it might have fallen toward a star, missed, and in the process was accelerated to extreme speeds. Well, let's leave astronomers to search for more evidence to confirm this exciting theory. Meanwhile, we're heading further to the binary star system 55 Cancri. It lies 41 light-years away from Earth and hosts an amazing planet, 55 Cancri E, also known as Janssen. This is a scorched super-Earth, 8 times the mass of our planet, and it orbits its star in just over 17 hours. Yep, the year on this planet is shorter than 1 day on Earth. Plus, it's 25 times closer to its star than Mercury is to our Sun. No wonder the planet's surface reaches blistering temperatures of 4,350 degrees Fahrenheit. That's hot enough to melt nearly any known metal. Back in 2010, a study found out that the host star of 55 Cancri E had an unusually high carbon-to-oxygen ratio. If this ratio was also true for the planet, it would mean that 55 Cancri E might have huge quantities of carbon. And the coolest thing? It would be in the form of diamonds. It'd make this space body a literal diamond planet. Sadly, some follow-up studies discovered that the carbon-to-oxygen ratio on the planet was less extreme than originally thought. It makes the idea of a diamond-encrusted world less feasible. On the bright side, planets don't always have to match the composition of their host stars exactly. If some other process topped up the carbon on 55 Cancri E, it could still be the most precious planet known in the universe. Definitely worth a visit. But let's leave the diamond planet behind and fly to Vega, which holds a special place as one of the brightest and most important stars in the sky. The brightest of other stars is measured against the brightness of Vega on a special magnitude scale, where Vega's magnitude is 0. A star with a magnitude of 1 is 2.5 times dimmer than Vega, and a star with a magnitude of -1 is 2.5 times brighter. Vega is also a pole star, although not at the moment. Right now, Earth's axis points toward Polaris, the North Star, but Earth's axial tilt draws a circle over 26,000 years, and Vega will again be the pole star in about 12,000 years. Just you wait. But the coolest thing about Vega, which sets it aside from other stars, is that it's not shaped like a perfect sphere. Unlike the Sun, which rotates slowly and is almost spherical, Vega spins very fast, completing one rotation in just 12.5 hours. And it causes it to bulge at the equator, taking on an egg-shaped appearance. And now, get ready for the most dangerous encounter of them all. But first, I must warn you. Even though space is unimaginably vast, it's populated extremely sparsely. The universe's average density is equivalent to 6 protons in 35 cubic feet. But some areas, known as voids or supervoids, contain even less matter. These regions are enormous and can span 30 to 300 million light-years, and there's almost nothing there. There are also places in the universe where time and space are distorted in ways that challenge our human comprehension, like binary black hole systems, where 2 massive black holes dance around each other before eventually merging. As they spiral closer, they release immense gravitational waves that ripple across space-time. The first detection of such waves was made by the Laser Interferometer Gravitational Wave Observatory in 2015, when it recorded the final collision of a black hole pair. In the final 20 milliseconds before the merger, the black holes released more gravitational energy than the total energy emitted by all the stars in the observable universe during the same period. But that's not all the universe has to offer. Once you start exploring, you can come across exoplanets, like Corot 7b, where rock clouds form and send pebbles raining from the skies, or Kelt 9b, the hottest known planet with surface temperatures reaching 7,800 degrees Fahrenheit, or Tres 2b, the darkest planet ever discovered. It absorbs over 99% of the light it receives, making it blacker than coal. So, as you can see, in the vast, almost incomprehensible scale of the cosmos, mysterious, fast-moving objects, strange planets, and immense voids serve as a reminder of how much we have yet to learn about the universe.
Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is: an asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kind of like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet. So it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So, the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards. Now imagine something so powerful that it could rip the atoms of your body apart in a fraction of a second. Ow! This something is soundlessly dashing through space, not extinct, not alive, stuck in between. If this terrifying monster were moving towards Earth, we'd be doomed. So, is it? Astronomers have found a fast and powerful space object zooming through our home Milky Way galaxy at over 110,000 miles per hour. That's faster than any rocket we've ever made. This bizarre space object got its name of a zombie star, all because it's the leftover part of a star that passed away a long time ago but is still moving. This zombie star is a kind of an object called a magnetar, a super small, super heavy ball about the size of a city but heavier than the Sun. That makes it one of the densest objects in space. Only black holes are denser. Hey, let's not forget about me, huh? Magnetars also have an incredibly strong magnetic field. The one our zombie guy has is 100 trillion times stronger than Earth's. That's so strong that if the magnetar came close to Earth, it could wipe out every credit card on the planet just from its magnetism, and we couldn't shop anymore. Plus, if a person got too close to a magnetar, like 600 miles or so, it could pull their very atoms apart, and they couldn't shop anymore. Luckily, this magnetar is very far away and not coming near us. When it was first discovered, it was about 15,000 light-years away from Earth. That's a huge distance, so you don't get to worry about your atoms being disconnected yet. Astronomers first spotted the zombie magnetar in 2008. And since only about 30 magnetars are known in our galaxy, it was a lucky and rare find. Scientists use space telescopes like Hubble and Gaia to watch it over time. That's how they discovered it was moving much faster than they thought. Now, astronomers are trying to figure out how this zombie star got such a big kick. At first, they thought that, like most magnetars, this one was born when a giant star exploded in a supernova and the leftover core became a super-dense neutron star. According to their theory, it could have happened near something called supernova remnant HB9. That would make sense since most magnetars are created this way. But when they tracked its movement, they found that the zombie star was moving too fast and going in the wrong direction to have come from HB9. They traced its path thousands of years into the past and still couldn't find any exploding star or star cluster it could have come from. This means scientists now have one more mystery on their hands. Where did the zombie star come from, and how was it made? One explanation is that it came from a white dwarf, which is the leftover core of a smaller star like our Sun after it runs out of fuel. Now normally, when white dwarfs explode, they're destroyed completely. But in rare situations, instead of blowing apart, a white dwarf might collapse into itself and turn into a neutron star. This neutron star could then become a magnetar. This unusual way of forming a magnetar also gives clues about another mystery: fast radio bursts, or FRBs. These are very quick and powerful flashes of radio energy from deep space. Some FRBs come from galaxies that are so old there shouldn't be any exploding stars left. But if magnetars can be born from collapsing white dwarfs, that might explain how those FRBs are still happening. In any case, learning how magnetars form could help us explain many strange and powerful events we see across the universe. But so far, the investigation is still on, and no answers have been found yet. Zombie stars wandering across the universe isn't the only mystery we haven't solved yet. At one point, you might come across one of them while traveling through the cosmos. It looks like nothing. At a distance of 700 million light-years away from Earth, there's a hole, a blank void that has very few galaxies. This is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there thousands of times over. It's the mysterious Bodies void in the constellation of Bodies. Yeah, makes sense. You see, galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters. But between these clusters and threads, there are huge, empty voids that hardly contain any galaxies. Such voids make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Bodies void is one of the most massive ones. It has even earned the title of Supervoid. Astronomers think it might be the result of a few smaller voids merging. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, I wasn't around then, all the matter in the universe was packed together quite tightly. Astronomers even thought it was something like a uniform soup. But soon, random quantum fluctuations started disturbing this matter. Some areas became denser, and their gravitational pull became stronger. They began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. If you visited a star cluster called Palomar 5, you'd forget all about voids and supervoids and even zombie stars. Instead, you'd need to concentrate on surviving, since the region is hiding a swarm of over 100 black holes right in the middle. And those black holes aren't just sitting there, they're at work, shaping the cluster nonstop. Palomar 5 is a group of stars located about 80,000 light-years away from us. Normally, clusters like this are dense and tightly packed, with stars all bunched up together. But Palomar 5 is different. It's spread out and has a huge tail of stars, stretching across 30,000 light-years. This beautiful tail is called a tidal stream. It's like the stars are spilling out of the cluster, creating a long river of light. Tidal streams like this are rare and hard to study. Globular clusters like this one are super old. Some are almost as old as the universe itself. But Palomar 5 also stands out because it's the only cluster we know about that still has a tidal stream attached to it. And the black holes inside the cluster might be to blame. They're pulling on the stars in the cluster, messing with their orbits, and slingshotting them right out of the cluster. Or would that be sling shooting? I don't know. Anyway, these stars are what make up the tidal stream. Over time, more and more stars get flung out. Palomar 5 has way more black holes than expected. About 20% of the cluster's mass is made up of black holes, over 100 of them, each about 20 times the mass of our Sun. Of course, Palomar 5 isn't going to last forever. In about 1 billion years, the cluster will completely fall apart. By then, all the stars will have been gone, leaving behind just the black holes. And these black holes will orbit the Milky Way, like a ghostly remnant of a cluster that used to be there. Even though this cluster is creepy enough, there's something even more eerie you can see in space. Thick clouds of gas and dust called nebulae. One of the most unusual ones is probably NGC 2392, located 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and became popular because of its unusual appearance. It's basically a disk of material with a ring of comet-shaped objects. The tails of these objects stream away from the star at the center of the nebula. The bizarre orange streaks in the outer part of the cloud stretch light-years away in all directions. The middle resembles a ball of twine, but in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Wow.
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob, and how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome.
There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers, a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about 1/3 of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle, but it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years? That's some million-dollar questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquilitas, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure, there's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up.
Doctor, I can't understand what's going on. I feel dizzy and, how do I say it? I'm tilting. It didn't happen overnight. Like, I didn't wake up and couldn't stand straight. No, one day, I felt that my axis had shifted by 1 inch. Another day, it was 2 inches. And once, you won't believe it, it was 31.5 inches. That's alarming. What if I accidentally turned upside down and all my inhabitants fall off my surface? Ah, dear Earth. We ran some tests and are ready to explain an unfortunate combination of factors that has affected your axis. The last one will perhaps be the most unexpected and upsetting. It all started back in March 2011, when a devastating magnitude 9 earthquake struck off the coast of Japan. It was so powerful that not only did it shift Earth's axis, but it also shortened the length of the day. This earthquake displaced our planet's axis by approximately 6.5 inches and may have moved Japan's main island by about 8 feet. Like other similarly massive earthquakes, it also altered Earth's rotation speed. To make it easier, let's compare it to a spinning ice skater. When a skater pulls their arms close to their body, they spin faster by concentrating their mass near the axis of rotation. Something similar happens during the most powerful earthquakes. They shift Earth's mass closer to its rotational axis, causing it to spin faster and shortening the day length. The calculations showed that the Japanese earthquake sped up Earth's rotation by about 1.8 microseconds, which is about 1.8 millionths of a second. Not a big deal, but at the end of the day, every nanosecond counts. For comparison, the infamous Indonesian earthquake shortened the length of a day by 2.68 microseconds. It struck on December 26, 2004, at 0:58 UTC. The epicenter lay off the western coast of northern Sumatra, Indonesia. This powerful undersea earthquake triggered devastating tsunamis that swept across the Indian Ocean, causing widespread destruction and immense loss of life in countries like Indonesia, Sri Lanka, India, and Thailand. Even coastal areas as far as East Africa had severe damage. The Earth's magnitude, initially recorded at 9.0 on the Richter scale, was later adjusted to between 9.1 and 9.3, making it the most powerful earthquake ever recorded in Asia. The faulting, that's when Earth's crust completely breaks and its parts slide past each other, lasted between 500 and 600 seconds, and it was the longest duration ever observed. The immense force of the quake caused the entire planet to vibrate by at least half an inch and triggered other earthquakes as far away as Alaska. All that immense energy the earthquake released caused subtle but quite measurable changes to Earth. The shift in mass slightly changed the planet's rotation, shortening the day. It also caused a small wobble in Earth's axis from 1 to 2.4 inches toward 145° east longitude. So, when it comes to changes in Earth's rotation speed and axis, it's all about the redistribution of mass. This can happen naturally through disasters, but human activities can also trigger it. Take the Three Gorges Dam, for instance. This massive structure across the Yangtze River in China's Hubei province may seem to be an engineering triumph, but it's pretty ambiguous. Finished in 2012 after nearly 20 years, this massive dam is 7,660 feet long and 607 feet high. And yes, It is so big that it can affect the way our planet spins. Its reservoir is capable of holding 9.5 cubic miles of water, has enough mass to slightly alter the Earth's rotational inertia, slightly slowing the planet's rotation. According to NASA, the Three Gorges Dam Reservoir could shift Earth's pole position by almost 1 inch and increase the length of a day by 0.06 microseconds. Dams aren't the only worry. If polar ice melts, water rushes into the oceans, hiking up sea levels, especially near the equator. This mass shift slows Earth's spin way more than dams do. You won't feel it day to day, but it can affect ultra-precise equipment, such as atomic clocks. To fix this, scientists suggested a negative leap second, making a minute 59 seconds, to balance Earth's spin changes. Okay, so you're thinking you've got nothing to do with all those tilts. You don't build dams, right? Bad news. If you take regular showers, you're part of it too. Every time you turn on the tap, you're affecting Earth's tilt just a tiny bit. Thing is, our planet is always shifting and adapting, so even small actions like using water can influence its orientation. Over the past 2 decades, groundwater pumping has caused the Earth's tilt to shift by 31.5 inches. This water redistribution is equal to about 0.24 inches of sea level rise. It turns out that among climate-related causes, groundwater redistribution has the largest impact on the drift of Earth's rotational pull. But what is groundwater? It's the water stored beneath the Earth's surface, filling the spaces in soil, sand, and rock. It comes from rain and other precipitation that seeps into the ground, collecting in underground reservoirs, aquifers. Unlike rivers and lakes, groundwater stays below the surface, acting like a natural water reserve. Thanks to it, we have a steady supply even during dry periods. Many people, especially in rural areas, rely on groundwater as their main source of drinking water. Farmers use it to irrigate crops, while industries depend on it for manufacturing and cooling systems. It sounds pretty harmless, doesn't it? How can something so useful cause our planet to shift? Well, a study covering data from 1993 to 2010 revealed that we've pumped about 2,150 gigatons of groundwater in that time. And this large-scale water removal has shifted the Earth's tilt and rotation. After we use groundwater, much of it eventually flows into the oceans, contributing to rising sea levels. In areas like Western North America and Northwestern India, people use a lot of groundwater, and it may have a connection to these shifts. Yikes, let's face it. All these findings are rather disturbing. But you know, understanding the impact of groundwater use is already a huge step in the right direction. Hey, I'm not done yet. This tilting issue isn't just about stuff happening on Earth. We also need to look at space. We've talked a lot about water, right? Well, you know that the moon has a big role in that. Its gravity is super important for forming tides and all that. So one more thing that affects our planet a lot is the gradual movement of the moon away from Earth. These two bodies interact gravitationally, which makes Earth's rotation slow over time, even though significant events like earthquakes occasionally speed it up temporarily. How did we figure it out? Glad you asked. Once, someone paid attention to ancient corals. After analyzing them, scientists realized that Earth had once rotated much faster. The thing is, corals grow by laying down thin layers of calcium carbonate. They do it daily, and variations reflect seasonal changes. By counting these layers, scientists have calculated the number of days in a year millions of years ago. They found that Earth had about 420 days per year 444 to 419 million years ago. But over time, the moon's influence had caused Earth's rotation to slow. And now we only have 365 days in a year. I feel robbed, you know? At the moment, the Moon is moving 1.5 inches away from Earth each year. That's about the same speed at which your fingernails grow. Astronomers have figured it out with the help of special mirrors placed on the Moon during the Apollo missions. For over 50 years, researchers have been sending laser beams to these mirrors and measuring the time it took for the light to bounce back. In any case, dear Earth, at the moment, your condition isn't critical. As for your inhabitants, they won't fall off your surface, all thanks to your gravity, pulling them toward your center. Just don't switch it off, and everything's going to be fine. Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those two stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries. This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass, or a GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of two stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how big or bright it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the two stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, researchers concluded that Polaris B is much older than its bigger sibling, but it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's North Pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once two stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities, since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories have been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis Earth spins around and extended it over 300 light-years past the North Pole, at the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole, but one day we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South poles won't always point towards the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars and back again. One day, the title of the North Star will go to Vega. It's the 5th brightest star in the night sky and the 2nd brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it'll regain this status in 12,000 years or so. This star is located a mere 25 light-years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old star system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a Lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 15-inch refractor, and it happened again in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are 2 areas, an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution. These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for two reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it, the Ancyloneuma alaskana and the Ancyloneuma nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile deep ice core extracted from the center of Greenland. They found that the soil had traces of willow wood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it. Giant vase-like sponges, otherworldly jellyfish, segmented worms covered with bristles, and large octopuses are the newest Antarctica discovery. Scientists found them after a giant iceberg had broken away, and it turned out to be a treasury of ancient life under ice. In January 2025, a huge iceberg the size of Chicago, called A24, broke off from Antarctica's George VI ice shelf, which is a large ice shelf about 280 miles long, 12 to 43 miles wide, and around 820 feet thick. In the summer, which lasts from November to late February, the ice shelf melts at the surface, and meltwater ribbon lakes form. They're elongated and ribbon-like. That's how they got their name. Anyway, when the iceberg floated away, it left part of the ocean floor wide open, and it was a spot no one had ever seen before. Scientists on the research ship Falkor 2 were nearby in the Bellingshausen Sea. As soon as they heard about the iceberg, they immediately changed their plans. They understood that it was a super rare chance to check out something unknown and amazing, like lifting a rock in the forest to see what's hiding underneath. The researchers used an underwater robot named Sebastian and explored the deep sea for 8 days. They went as deep as over 4,200 feet. Down there, they found a hidden ecosystem. There were big corals and sponges literally packed with sea animals. A whole world under the ice. The researchers thought they'd find some life down there, but they didn't expect to see so much. And this underwater ancient life wasn't just surviving, it had been thriving in that harsh, icy place for a really long time. Anemones that looked like fluffy little trees, sea spiders, ice fish, octopuses. The research was live-streamed to scientists from all over the world, and those live streams are actually in open access. The coolest thing was that some discovered creatures seemed to be new species. Yes, there are probably new species in Antarctica in 2025, and some might only live in this region. That's because Antarctica isn't just really far away, it's been cut off from the rest of the world for millions of years. The Antarctic circumpolar current surrounds it, like a big water moat surrounding a castle. But even if it turns out that those species are not new, the scientists have still found snails, worms with bristles, crustaceans, like tiny crabs and shrimp, and a species of the phantom jellyfish. Those are super rare and look otherworldly. Their official name is too complicated, so let's just call them the giant phantom jelly. This jellyfish is huge. Its bell, the round umbrella part on top, can be more than 3 feet wide. It has 4 long arms that trail behind it. Each one as long as 33 feet, about as long as a school bus. Scientists first caught one way back in 1899, but it took them 60 years to realize it was a totally new kind of jellyfish. The phantom jellyfish has a see-through purplish body that looks kind of ghostly. Instead of normal jellyfish tentacles, it has these ribbon-like arms that help it catch food and pull it into its mouth right in the middle. Even though jellyfish don't have brains like we do, researchers watching the giant phantom jelly noticed something surprising. The otherworldly creature seemed to move its arms very carefully and with control, especially when swimming through tight spaces on the seafloor. It looked like it was being very cautious and deliberate. Ugh, creepy. Another sentient being? Jellyfish have a simple nerve net instead of a brain, which helps them sense the world around them. But the way this phantom jelly moved made scientists think it might be smarter or more coordinated than other jellyfish. Studying it can help scientists learn how animals without brains still manage to explore and survive in tricky places underwater. Another cool find was little worms called bristleworms. Scientists call them polychaetes. But let's stick with bristleworms because it kinda sounds fun. Lots of different kinds of them live in super cold, deep parts of the ocean. Bristleworms have bodies made of many segments, and they have tiny little bristles all along their sides. These bristles help them move around, feel what's near them, and even protect themselves from danger. One cool example is the Antarctic scaleworm. It's a type of bristleworm that lives in really cold, deep waters and has shiny, golden bristles that make it look pretty fancy. During Antarctic deep-sea exploration, the team also found giant sponges shaped like vases. Usually, sponges grow very slowly. So to get that huge, they must have been growing there for a really long time, maybe even hundreds of years. Their size shows that the deep-sea animals living around them didn't just move in recently. Those sea creatures have been there for decades and managed to form thriving communities under the ice. So, it really was ancient life hiding under all that ice. And that surprised scientists a lot. In older studies, people used to drop cameras through holes in the ice or visit iceberg areas long after the ice had broken off to explore hidden ecosystems. Back then, they mostly saw bare, empty seafloor with just a few living things. But this time, the team arrived just weeks after the giant iceberg broke away, and they got to see what was hiding right underneath it. The first 9 miles behind the ice shelf can hide rich and busy ecosystems. The area is dark, cold, and hidden for ages, and still, all kinds of creatures live there. This shows that life can survive in places that seem too harsh or frozen for anything to live. On the other hand, finding all this life down there isn't super surprising. Lots of animals live in dark, cold places underwater, so it makes sense that they'd be under the ice shelf too. The ice kind of hides them and keeps them safe from anything going on above. But what's weird is how many different kinds of creatures live there, even though it used to be a really closed-off space. It actually looks a lot like the seabed in parts of Antarctica that don't have ice on top. How can that be? Usually, tiny plants called phytoplankton grow near the surface where sunlight hits. Little shrimp-like animals called krill eat those plants at night. When krill get full, they sink down and bring food and nutrients to the ocean floor. Even their waste helps feed the deep-sea creatures. But if there's a huge ice cap above, sunlight can't get through, so no plants can grow there and no krill bring food down that way. Scientists thought this would mean less food and fewer animals down there, but they found a lot of life anyway. Turns out, food and nutrients probably sneak in under the ice, carried by underwater currents, kind of like rivers flowing under the ocean. Scientists found some animals that lived a long time, so it looks like those currents, which mostly come from melting glacier water, bring enough food to keep the ecosystem healthy and full of life. No one really knows what's going to happen to all that deep-sea life now that the iceberg has floated away. Those creatures have lived under the thick ice for who knows how long, in super stable, pitch-black conditions. Obviously, they're not exactly fans of change, so losing that icy roof might totally mess with their whole setup. One of the scientists mentioned that the ice shelf the iceberg came from has been creeping backward, like 25 miles over the last 50 years. That's a part of a bigger pattern. Antarctica's ice is melting faster and faster, which pushes sea levels up around the world. That's why this Antarctica discovery matters. The team's trying to figure out not just what's happening now, but how this hidden ecosystem fits into the bigger picture. If we can understand how this place is changing over decades or even centuries, maybe we can predict what's coming next. And it's pretty amazing that breaking ice can tell us so much, right?
You're lazing around on the deck of the ship when you see something whitish-gray covering the horizon. Like in a horror movie or your worst nightmare, this weird fog is nearing the vessel. It's infinite. You can't see where it starts or where it ends. Soon it makes the ship look like a grain of sand in a vast desert. That's when the realization hits. It's an iceberg, and your ship is likely going to repeat the Titanic's fate. Now, all this is a very likely scenario, since the world's biggest iceberg, A23A, is on the move again after months of spinning in a huge water vortex. And it's actually the second time in just a couple of years that this massive chunk of ice has broken free. The first time was in 2023, when the berg went wandering around after being stuck on the seafloor for a staggering 37 years. The thing is huge, about 3 times the size of New York City. It also weighs nearly 1 trillion tons. The giant chunk of ice first broke off from Antarctica's Filsner ice shelf back in 1986, but instead of floating away, it got grounded on the seafloor just a few miles from where it started. Because of that, it melted much more slowly than most icebergs. In December 2023, A23A finally broke free and started to drift away from Antarctica. But it didn't get far before getting stuck again, this time near the South Orkney Islands. It got trapped in something called a Taylor column. That's a huge spinning water current that forms when ocean currents swirl around an underwater mountain. At one point, A23A was rotating around 15 degrees counterclockwise every day. Luckily, as of December 2024, the iceberg escaped the Taylor column and is now slowly moving again. Researchers are super curious to see if it'll follow the same path as other giant icebergs that have broken off from Antarctica, or if it'll find its own unique way. Such enormous icebergs, such as A23A, release nutrients into the water as they melt, and it can actually create hot spots of life in parts of the ocean that are usually pretty empty. But there's still a lot we don't understand about how the size, shape, or origin of the iceberg might affect that process. So, to figure it out, scientists have been collecting water samples from the areas A23A is expected to pass through, and they'll keep collecting samples as it drifts along. Hopefully, it'll give us a better idea of how massive icebergs like this one influence the ocean around them. By the way, the glacier our monster of an iceberg was once part of could be very, very old, literally ancient. In Antarctica, the oldest glacier ice might be close to 1 million years old. Over in Greenland, the oldest glacier ice is more than 100,000 years old. And in Alaska, the oldest glacier ice ever recovered, found in a basin between Mount Bona and Mount Churchill, is only about 30,000 years old, a mere child. At the same time, in a typical Alaskan Valley glacier, it only takes about 100 years for newly formed ice to travel through the entire length of the glacier. For something like Bering Glacier, which is Alaska's largest and stretches over 140 miles, the ice can move through the whole thing in less than 400 years. And that's a lot of movement for such a massive glacier. Now let's move on to Iceberg Alley, a stretch of the Atlantic Ocean that runs from the Arctic to Newfoundland. If you want to see as many icebergs as you can, that's the place to be. Tons of icebergs float through this place every year. Most of them come from Greenland. In spring and summer, big chunks of glaciers break off and get carried by north-south currents through Baffin Bay into the Labrador Sea, where they eventually melt. Some icebergs also come from Canada's shoreline, traveling through the Davis Strait and into the Labrador Sea before drifting along Newfoundland's eastern and western coasts. These massive ice chunks are really old too, about 10,000 years. Every year, about 400 to 800 medium and large icebergs pass through Iceberg Alley. How fast they drift depends on their size, shape, currents, waves, and wind, but the average speed is less than a half mile per hour. Now, there are 6 types of icebergs that make their way through Iceberg Alley. Tabular icebergs are flat slabs of ice, much wider than they are tall. Blocky icebergs have steep sides and sharp angles, like cut-off pyramids. Wedged icebergs have one steep side and one sloping side. Dome icebergs have a rounded top. Pinnacle icebergs have one or more steep peaks sticking up. And dry dock icebergs are U-shaped with a hollowed-out section. They all look incredible. Comment below which is your favorite type. Anyway, as these icebergs drift south, the warmer water speeds up their melting, making them pretty unpredictable and sometimes dangerous. Nowadays, satellites help track medium and large icebergs to prevent accidents, but smaller icebergs can still be risky for small boats. One iceberg made headlines in 2018 when it got unusually close to the Newfoundland village of Fairyland. Pictures of the giant iceberg towering over the village's houses went viral. It got stuck in a 330-foot deep water, which turned out to be too shallow for its massive size. And now I'll take you on an unusual journey to the past to witness the birth of something beautiful and equally disastrous. Its very existence led to one of the greatest tragedies in history. Watch, an enormous chunk of ice is breaking off a glacier in southwest Greenland. It's made of snow that fell over 100,000 years ago, when mammoths were still wandering around the planet. The enormous iceberg starts its long journey. It stretches more than 1,700 feet in length and weighs 75 million tons. Despite its size, it's pretty peaceful and stays far away from ships and the busy transport routes near where it was born. But then, it starts floating south, much farther than most icebergs ever get. Usually, icebergs like this melt way before they reach such warm waters. Out of the 15,000 to 30,000 icebergs that drift away from Greenland's glaciers every year, only about 1% make it all the way to the Atlantic. So the fact that this iceberg keeps going and reaches over 5,000 miles south of the Arctic Circle by April makes it truly unique. Even after months of melting, this block of ice is still incredibly massive. It weighs around 1.5 million tons, which is almost twice as much as the Golden Gate Bridge. Above the water, its visible parts tower more than 100 feet high. But like most icebergs, the majority of it, about 90%, is hidden below the surface. The iceberg's story takes a tragic turn on April 14, 1912, when, guess what? Yep, it comes across the ocean liner Titanic. The ship is about 370 miles from Newfoundland in the North Atlantic Ocean when the iceberg seems to appear out of nowhere. The crew doesn't spot it until just minutes before the crash. Why don't they see it sooner? That's a good question. Now, most people imagine icebergs as tall, bright, white chunks of ice, maybe even covered with snow. But in reality, icebergs come in all sorts of colors. Some are striped, patterned, or even have candy-like swirls, and they can also be black. There are two ways an iceberg can turn black. When the ice is extremely pure, with no bubbles or cracks, then it absorbs all the light instead of reflecting it, making it look black. Or a volcanic eruption can cover a glacier in ash. If ice from that glacier breaks off, it can have a dark or black color. Now, scientists still aren't sure why the Titanic's iceberg looked dark, or even if it really did. But one sailor who was on the lookout in the crow's nest said it seemed black. Another described it as gray or dark gray. One theory is this iceberg could have been a blackbird, which forms when the top part melts, causing the iceberg to roll over. If the bottom is smooth enough to absorb light, it looks dark. But even if the iceberg wasn't truly black, nighttime could have made it much harder to spot. Icebergs don't reflect much light, especially if they're jagged or vertical. They end up blending into the dark, shimmering ocean. Without radar, icebergs at night are incredibly hard to see, which is probably why the Titanic's crew didn't notice it in time.
Look at those lush coniferous forests and tundra. What a wonderland. You may have mistakenly thought it's Canada, but it's not. It's Antarctica, about 34 million years ago. So what makes Antarctica this frigid today? It turns out a mix of dropping carbon dioxide levels and some tectonic shuffle played a huge role in transforming this ice-free paradise into the frozen continent we know now. About 50 million years ago, CO2 concentrations were sky-high, strutting around at around 1,000 to 2,000 parts per million. But as those levels tumbled down, global temps started to drop, paving the way for the mighty ice sheets that later took over Antarctica. While the CO2 dive was happening, tectonic activity was also working its magic. The big split between South America and Antarctica opened up the Drake Passage, which created the Antarctic Circumpolar Current. This powerful current acted like a bouncer, keeping warm air and ocean currents from crashing the Antarctic party, and helping keep things rather frosty. If you mix up Australia and Antarctica, you're not that wrong. These two continents used to be one. If you mix up Austria and Australia, it's much worse. By the way, don't fall for the internet myths and memes. There's no help desk in Austria specifically for people who intended to fly to Australia. Now, look at this magnificent Australian pink beach. It's precious, and not in a figurative sense. Those mysterious pinkish sands are actually garnet, and it's widely used in jewelry. Geologists studied those sands and came to the conclusion that the garnet contained there is older than local mountains. That doesn't make sense, right? In fact, it does. You see, Australia didn't used to be this very detached continent as it is now. Many millions of years ago, Australia and Antarctica were part of the supercontinent Gondwana, and glacial erosion released the garnet, which eventually made its way to the beach. These sands formed when South Australia was flat and chill, long before the mountains appeared. Most garnet gets washed away, but this batch has a rich history, tracing back to glacial rocks in the Transantarctic Mountains. So this pink sand comes from an ancient mountain range hidden under Antarctic ice. Not only does Antarctica ice hide gems like garnet, if you look harder, you might find entire buildings. Sounds insane, but this is exactly what a British explorer did. His name is Chris Brown, and he uncovered an entire building beneath the ice. He was traveling to the pole of inaccessibility, and it all started with a bummer. Chris and his son had their plane broken. Suddenly, they spotted a lone bust peeking out of the snow. This place was an old meteorological station. Despite freezing conditions, Chris and his son Micah had a blast exploring. Chris is on a mission to conquer all 7 earthbound poles of inaccessibility and has tackled 5 so far. I guess you already know that Antarctica is the largest desert on Earth. much larger than the Sahara or the Gobi. Still, despite being the driest continent on Earth, it boasts a seriously weird waterfall. Nestled in the mesmerizing McMurdo Dry Valleys, it's 5 stories tall and looks like it's gushing blood. It's even called Blood Falls. It may look outlandish and even frightening, but its nature can be easily explained. The water that creates this crimson cascade was once a salty lake, but over time, it became sealed off from the outside world when glaciers formed on top of it. Now, this ancient water hanging out 1,300 feet below the surface has cranked up its salt levels to 3 times saltier than the ocean. This salt water is also loaded with iron and gets 0 oxygen or sunlight. When the iron-rich water trickles through a crack in the glacier and meets the air, it rusts up, turning dark red. You may have mistakenly heard that no bug species belongs to Antarctica, but it's not exactly true, because there's this tiny Antarctic midge living there. Plus, there are some spiders too. Those aren't your average spiders hanging out in the darkest corners of your apartment. Those are critters lurking in the chilly darkness of the Antarctic ocean floor. These little marine creepers are actually arthropods and can stretch around 20 inches across. As if that wasn't bizarre enough, they also breathe through little holes in their legs. Quick question. What's the color that you associate most with Antarctica? I'm sure it's white. That's my association too. However, Antarctica may look like a slice of watermelon. That colorful snow comes courtesy of a tough little algae called Chlamydomonas nivalis. When things start to warm up during the Antarctic summer, these little guys release their vibrant red and green spores, painting the snow in wild and funky colors. But it's best to steer clear because that snow is not just a pretty sight. It's also toxic and definitely not edible. Searching for fossils is always a blast, but when you're in one of the most remote spots on the planet, it gets even more exciting. A diverse team of scientists recently hit the mother lode, pulling in over a ton of fossils from ancient marine life, dinosaurs, and birds from the late Cretaceous period, about 71 million years ago. Their adventure kicked off with a flight to South America, followed by a 5-day trek through the infamous Drake Passage. Upon reaching Antarctica, they set up camp using helicopters and inflatable boats. You might be thinking, why dig in Antarctica with all that ice? Well, it turns out there are places where rocks pop up, depending on the season. The team went to James Ross Island, located in the Antarctic Peninsula, and they went there during February and March. And that's one of the few parts of Antarctica where in summer, rocks are exposed, and those rocks can come from the age of dinosaurs. The expedition was a success, as they discovered over a ton of remarkable finds. Next up, the fossils will head to Chile before making their way to Pittsburgh's Carnegie Museum of Natural History. Among their discoveries, they found relics dating back about 71 million years, alongside some around 67 million years old, including plenty of snails, clams, and various marine creatures. Yikes! Look at this creepy sea worm. It could live in LA and be a star in a horror movie, but it chooses to call the chilly waters of the Southern Ocean near Antarctica its home. These worms can grow up to 8 inches long and 4 inches wide, but don't let their spooky exterior trick you. Research suggests they might actually be superheroes in disguise, playing a vital role in keeping ecosystems buzzing. Now, see that head? It's not really a head, it's just a retractable throat that helps this toothy creature chow down on its meals. Antarctica has many creepy critters to offer. Let me introduce you to the Antarctic strawberry feather star. It's not like Patrick from SpongeBob though. It's more like a deep-sea creature straight out of a horror movie. Picture this. 20 wiggly arms, some stretching up to 8 inches, all decked out with these bizarre little bumps. Yikes indeed. Back in 2014, scientists buried 34 seismic monitors in the snow on the Ross Ice Shelf, which is huge. Think of it as an ice slab the size of Texas, just chilling over the Southern Ocean. These clever little machines picked up a nearly non-stop buzzing, Even though our human ears usually can't catch these low-frequency sounds, scientists have worked their magic and made them audible for us. They even shared the creepy audio online. A glaciologist from the University of Chicago says that if you could hear this vibration, it'd sound like a swarm of cicadas taking over the backyard in late summer. But these glacier explorers weren't trying to capture spooky tunes. They're actually on a mission to monitor the Ross ice shelf because things are heating up, literally, and the ice is melting faster than ice cream on a hot day. Ice shelves are like Earth's safety plugs, keeping all that massive ice from surging into the ocean. So what exactly is making all that noise? It's likely just strong winds whipping across ice dunes, creating a kind of natural vibration. Discovering hidden places on our planet is extremely exciting. Today, I'm taking you on a trip that you aren't going to forget anytime soon. But suit up, this is about to get very cold. You hop on a plane and land on the ice-covered island of Greenland. An unbelievable view of the Aurora Borealis, aka the Northern Lights, is greeting you. You can't believe your eyes. Your guide tells you how rare this phenomenon is. Usually, people spend days trying to hunt it down. You feel lucky and take your time to appreciate these beautiful dancing greenish lights. You're glad you brought your camera along, aren't you? Between clicks, you learn that the Aurora Borealis is the result of some rather rough events. This spectacular light show occurs when energy particles from the sun slam into Earth's upper atmosphere. On day 2, you continue to explore the place by air. This may not come as a surprise, but Greenland is one of the world's largest islands. This time, on board a helicopter, you can see the infinite icy landscape. In case you're curious, you're now flying over 656,000 square miles of thick ice. Oh, what's that down there? It looks like a family of polar bears. You don't want to get too close, of course. The conditions in Greenland might be too tough for people to live there, but some animal species do very well in this land of ice. Those are reindeer, wolves, and Arctic foxes. On your way to Greenland, you probably made a pit stop in Copenhagen. Denmark is one of the few countries that have commercial flights to Greenland. You didn't know this before, but you find out that the island is actually part of the Kingdom of Denmark. On a map, it's right between the Arctic and Atlantic Oceans. You're lucky to have a local pilot that tells you about the secrets hidden in this scenery. Under this 2-mile thick white surface, there's an entirely different world. A world filled with canyons, meteor-carved craters, and millennia-old plant fossils. You are beyond excited to go visit one of these spots, but of course, you'll have to use your imagination, as all of it is hidden under ice. Believe it or not, nearly 80% of the island's surface is covered with it. The first stop on your tour is Greenland's Grand Canyon. You land not far from it, somewhere in the northern part of the island. You may know that canyons are deep, narrow valleys with steep sides, but I bet you didn't know that the word canyon actually comes from the Spanish word cañón, which means tube or pipe. Now, this Grand Canyon has some similarities with the one in the US. First of all, in size. It's at least 460 miles long and up to 2,600 feet deep in some places. There's a true subglacial valley down there, and if you're wondering how this happened, well, the canyon had probably been formed by a river that had been flowing through Greenland before the ice took over. Oh yeah, Greenland hasn't always been covered with ice. It was once green, no pun intended. Many other icy places on Earth, such as Antarctica, were once covered in greenery. Scientists have figured out that in the past, Greenland was mostly ice-free. With the help of airborne radar, they made amazing discoveries. By the way, ice is invisible to radar technology. If you have trouble believing it, try putting an ice cube inside your microwave. It won't melt or heat up. A recent discovery of fossilized plants allowed researchers to estimate that Greenland used to be much warmer than they could imagine. 2021 research conducted by the University of Vermont found fossils of twigs and leaves, which left researchers very confused. They expected to discover sand and rocks in the deepest layer of ice, but instead, they found some clear proof of rich flora. Judging by what you've seen of the landscape, it's hard to believe that forests were once growing here. Today, you'll find some tundra vegetation on the coastal part of the island, and that's pretty much it. But according to the genetic material found in these fossilized plants, researchers believe the island used to be much greener. It's very likely that there were insect-filled forests with butterflies and beetles flying around, and the average temperature on the island varied from 50 degrees Fahrenheit in the summer to 1 degrees Fahrenheit in the winter. NASA's Operation Ice Bridge has flown over Greenland more than 100 times. This has allowed researchers to create 3D maps of the island and figure out the age of each layer of ice in Greenland's ice sheet. Ice sheets can help answer many scientific questions as they form over the span of thousands of years. They're layers of snow on top of more snow. The snow gets compacted into ice, which in turn creates what we call an ice sheet. Remember those fossils we were talking about? They're believed to be from the Eemian period, which was 130,000 to 115,000 years ago. According to the groundbreaking 3D footage from NASA, we can see 3 distinct climate periods within the ice sheet. The uppermost layer is quite flat and uniform. If you decided to dig deeper, you'd find the layer formed during the last ice age. It's more complex and rugged. The ice there is darker than what you see on the surface. If you let your mind wander, you can picture what this part of the world looked like when mammoths were roaming around. If you kept digging, you'd eventually find leftover ice from the Eemian period I've told you about. Now, canyons aren't the only unusual thing found under ice. If you could sneak a peek under all those layers of snow, you'd see an impressive mountain range and also plunging fjords. In 2017, scientists created a map that showed what Greenland had looked like without all that ice. There was a bowl-like depression in the middle of the enormous island. This depression was most likely an ancient lake. Around it, there was a circle of coastal mountain ranges. This scenery probably resembled the landscapes of modern Patagonia. Big mountains with snowy tops surrounding crystalline lakes. This ancient lake in Greenland is a wonder on its own. Imagine a pit the size of Rhode Island and Delaware put together. The lake is believed to have covered over 2,700 square miles, and back in the day, it was fed by at least 18 different streams. These crystalline blue waters were surely very inviting, and freezing of course. But if you ended up going for a swim, I'd say be careful, as the water could get up to 800 feet deep in some places. On day 3 of your adventure, you discover a true under-ice water park. While you're wandering around the ice-covered island, your guide tells you to be mindful of the cracks in the surface. These cracks are responsible for the modern-day aqua lounge going on down there. Meltwater and rainwater flow down the cracks in the ice all the way down to the riverbeds. This forms a landscape of jewel-like lakes and streams filled with crystalline water. Researchers estimate that about 60 small under-ice lakes exist there. And yes, they're actual lakes. Perhaps one of the most impressive hidden features on this island is a meteor crater. Under the Hiawatha Glacier, you can find a 19-mile-wide impact crater, big enough to swallow the city of Washington. Apparently, a mile-wide iron asteroid struck Earth's atmosphere within the past 100,000 years and chose Greenland as its landing point. If anyone had been around to see it, they'd have witnessed a real show, a white glowing fireball cutting through the sky. Scientists speculate that if it had landed on an ice sheet, it certainly vaporized both water and stone. Someone standing hundreds of miles from the impact site would have heard a deafening thunderclap and experienced hurricane-force winds. But it actually makes sense. The approximate speed of meteors entering Earth's atmosphere is 45,000 miles per hour. For comparison, that is 2.5 times the speed of a spaceship. It's bound to make some noise and leave a huge crater in the ground. In 2003, while following a grouper that suddenly disappeared below the waves in Chetumal Bay, Mexico, a lone fisherman discovered a mysterious hole hidden from sight. More than a decade later, his son returned with researchers to take a closer look. They started measuring. 100 feet, 160 feet, 425 feet. Still no bottom. As instruments descended into the dark, still water, the readings grew stranger. Warm, salty water where it shouldn't be. Currents rising from the darkness below. The latest readings showed over 1,372 feet and still no end in sight. Quiet, deep, and dangerous. It's Oumuamua, the latest and officially the deepest known blue hole on Earth, and it might be hiding something never seen before. Nature takes its time. Over thousands, sometimes millions of years, water slowly carves through underground rock. Then one day, the ceiling gives way, the ground collapses, and you're left with a massive hole. That's a sinkhole. Blue holes are just ancient sinkholes that filled with water as sea levels rose long ago. From above, they look like dark circular shadows, much darker than the water around them. All because they're super deep and sunlight can hardly reach the bottom. Some go hundreds of feet down and are almost perfectly vertical. Cut off from ocean currents, they create still, isolated environments that scientists are still trying to figure out. So, what makes Oumuamua unusual? Well, most famous blue holes like the Great Blue Hole in Belize are impossible to miss. You can spot them from a satellite. Oumuamua, on the other hand, is practically invisible. Like nature did its best to conceal it on purpose. Even with a drone flying right above it, it's barely noticeable. That's one reason it stayed hidden for so long. However, the true mystery became apparent after the researchers had done their initial scanning. In December 2023, scientists decided to explore the depths of Oumuamua by lowering something called a CTD profiler, which measures conductivity, temperature, and depth. As it went past 1,312 feet, they discovered something curious. Instead of cooling down, the water suddenly got warmer. It also became noticeably saltier, with readings that matched the open Caribbean Sea. But wait, Chetumal Bay is already part of the Caribbean, so what's the big deal? Well, Oumuamua is tucked far into the bay, and its depth is unusual for such a calm, protected environment. What surprises scientists is that water deep inside the sinkhole has the same temperature and salinity as the open ocean, even though it's cut off from it horizontally. What this means is that there could be subterranean tunnels or fractures connecting the deep hole to open seawater, not through the surface, but beneath the rock. Kind of like a secret pipe network, possibly dating back to the time of asteroid impacts. Oumuamua is located near the Chicxulub crater. It's where 66 million years ago, a giant meteor slammed into what is now the Yucatan Peninsula. It's widely believed to have caused a mass extinction event that wiped out dinosaurs. The asteroid didn't create Oumuamua, but it may have fractured the foundation, potentially making it easier for caves, tunnels, and eventually blue holes to form. Some speculate that these underwater connections could extend to other blue holes and hidden springs nearby. However, exploring Oumuamua is not just about maps and underwater tunnels. During the first expedition, researchers saw something strange. The water above Oumuamua was calm, while the rest of the bay had chaotic waves. Then, from the center of the hole, water started to rise upward, like a hidden spring gently exhaling. Not a geyser, not a splash, just a slow, steady surge, like something beneath had moved and pushed the water up. The fact that this happened only once made the following exploration intimidating for divers. They said that diving felt like encountering a living entity that moved and interacted with them in an intriguing and mystifying way. When you've got a place that deep, that dark, and completely cut off from the rest of the ocean, it's a door to the unknown. While it's probably too tight for the Lovecraftian sea gods to fit in there, it's not impossible that there could be species that no one's ever seen before, maybe even dangerous. It's speculative, but if the hole goes even deeper, any microbial life down there would likely be ancient and adapted to survive in extreme, hostile conditions. It doesn't have to be some scary sea creature. Even tiny, unfamiliar organisms could disrupt modern ecosystems if disturbed or released. There might be water from prehistoric times, or something left behind from the asteroid impact that wiped out dinosaurs. This place might be hiding an entire ecosystem that's been sealed off for literally ages. And that matters because if life can survive in such a strange, sealed-off place, It might survive in similar environments on moons like Europa or Enceladus. Also, some blue holes, like the Great Blue Hole, contain nasty stuff like clouds of toxic gas that can eat through equipment and even burn your skin. No wonder that divers felt like they were exploring something alive. Now, if you're wondering whether you can rent diving gear and actually go and explore this hole, the answer is no. Basic scuba gear requires certifications. Even dive shops won't rent to uncertified individuals, especially not for places like this. But even if certified, recreational divers can only reach a depth of about 130 feet. Going deeper takes special training, equipment, and a lot of caution. Even professionals rarely go beyond 1,000 feet, and when they do, it's with complicated, risky setups. At these depths, water pressure becomes a major obstacle, enough to crush most equipment not built specifically for it. So for now, Tom Jaw remains a mystery that's impossible to uncover while diving. The next stop is most likely sending an ROV, a remotely operated submarine equipped with cameras, arms, and sensors. It can go much deeper than any diver and stay down there longer. ROVs could help uncover layers of fossils, strange chemical zones, and even clues about past climate change. In most of the blue holes, it's possible to find life, sponges, corals, or fish. But the deeper you go, the more oxygen levels drop, which makes it hard for organisms to survive, even though some microbes live there. Among the few creatures found, there are shelled single-celled organisms called foraminifera and tiny worm-like nematodes. It's precisely because of these microscopic animals that we speculate that if life can make it in Tom Jaw's dark, salty, oxygen-free waters, maybe the same is true for other watery worlds. However, despite the enthusiasm around it, Tom Jaw is almost unnervingly empty and devoid of larger life. Even near the upper layers where oxygen levels are decent, no fish, no crustaceans, not even a tiny shrimp have been observed. Just tiny organisms invisible to the unaided eye. No bikini bottom, but to be fair, we haven't reached the bottom yet. Which brings us to the speculation. Is it possible that ROVs will never reach the ocean floor? The hole might be deeper than we expect or shaped in a way that makes it hard for our equipment to get accurate readings. It might have side tunnels, ledges, or twists that throw things off. It could also be that the walls are too unstable or the pressure and water chemistry mess with the sensors. In a way, it's like playing an underwater level in slow motion with a robot that can grab things and get damaged. Thankfully, scientists have other options. They can use underwater drones that work on their own, drop cameras that record as they sink, or map the hole from above using sonar. There's more than one way to check its depths. Even with all our technology, there are still places on Earth we haven't explored. We've actually mapped more of Mars than the ocean floor. Spacecraft can scan the entire planet while seafloor mapping is slow, costly, and limited by darkness and pressure. Still, Tom Jaw holds the record for the world's deepest blue hole, for now. The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the endgame here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places, like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
So, check out this creature. What do you think this thing is? Is it a plant, an animal, or maybe even some kind of wild fungus? At first glance, this fossil could pass for any of those ancient life forms. And honestly, scientists have been scratching their heads over it for over 150 years. But now, it looks like we might finally be cracking the case on this unknown species discovery. A long time ago, during the Devonian period, plants were just starting to grow on land. The tallest trees were only a few feet high, and animals hadn't even evolved backbones yet. Back then, massive natural towers up to 26 feet tall and 3 feet wide, looking like branchless cylindrical tree trunks, were rising from the ground. Hey, what a contrast with trees back then. When scientists first discovered fossils of those towering organisms, they were totally confused, as these strange prehistoric creatures didn't look like anything they'd seen before. Some thought they were weird cone-bearing trees. Others guessed they might be underwater plants like giant seaweed or lichens, which are partnerships between fungi and algae. The mysterious objects received a name, Prototaxites. When scientists studied them up close, their internal structure reminded them of a bunch of different things. They couldn't believe a 20-foot-tall fungus or algae could be real, but that's what the fossils showed. Then most scientists decided that Prototaxites were giant fungi. But still, something didn't feel right about it. In 2007, they decided to finally get the Prototaxites mystery explained and ran a chemical test on the fossils. So they looked at the types of carbon inside them and compared them to regular plants from the same time. If Prototaxites were plants, The carbon ratios would match, but they didn't. That means prototaxites weren't plants, and they received carbon in a different way, not by photosynthesis, but probably more like fungi do. But then again, they looked nothing like the mushrooms we know and love today. Prototaxites were giant, likely the largest living things on land at their time. And even if these strange prehistoric creatures were some fungi of their sort, then it's weird they don't have any living relatives today that would resemble them. So, if we put all this together, it looks like prototaxites are an entirely different and previously unknown life form that didn't leave any offspring. Now, prototaxites aren't the only unclassified organisms on Earth. About 600 million years ago, there were no fish, no sharks, no crabs. Just simple life forms like algae and bacteria drifting through calm, shallow seas. But some seriously strange creatures, completely unlike anything we see today, lived among them. They looked like underwater ferns, stood perfectly still, and absorbed nutrients straight from the water. These bizarre life forms were rangeomorphs. They ruled the oceans that were thick with nutrients back then. So rangeomorphs didn't need mouths, eyes, or muscles to survive and just soaked up whatever they needed. Some of them were as small as a finger, and others grew as tall as 6.5 feet. But as Earth entered the Cambrian period, the oceans became much more competitive. Fast-swimming creatures with limbs, eyes, and jaws showed up and ate the same food faster, and maybe even ate the rangeomorphs themselves. The chemistry of the oceans also started to shift, and the nutrient-rich waters became more like today's oceans, where food floats around in particles that active animals scoop up. So the rangeomorphs vanished forever, but scientists still find their fossils all over the world, preserved in ancient rock. They had an incredible fractal design, a pattern that repeated itself at every level, from the smallest branches to the full body. Using fossil clues, researchers built 3D computer models of what rangeomorphs looked like. They found out that these strange prehistoric creatures filled their space in a nearly perfect way. They were like optimized living sponges. But scientists still can't agree on where exactly rangeomorphs fit on the tree of life. At first, they argued over whether they were plants, animals, fungi, or something completely different. Now, most agree they were primitive animals, though they were so different that they might deserve their own unique branch, what scientists call a clade. And then there was Dickinsonia, another prehistoric creature that was so strange that scientists couldn't even agree on what it was for nearly 100 years. Some thought it was a giant single-celled amoeba. Others thought it was a type of lichen, or maybe a failed evolutionary experiment. This bizarre life form lived about 558 million years ago, long before dinosaurs, sharks, or even insects showed up. After many years of studies, Australian researchers finally got proof that Dickinsonia was an animal, and possibly the oldest one scientists have ever found. They solved the mystery thanks to really well-preserved fossil fat molecules stuck in the rock near the White Sea. These molecules were a type of cholesterol, the kind of fat found in animal cells. If cholesterol is present, it almost certainly came from an animal, sort of like animal DNA. Dickinsonia lived millions of years earlier than scientists had previously thought, and didn't look anything like modern animals. It had no head, no mouth, no arms, no legs, and definitely no organs. It was oval-shaped, like a giant pill bug or flattened jelly bean, with weird ridges running across its body. Some were tiny, but others grew up to 5 feet long, the size of a person. It didn't swim or walk, but was just lying on the seafloor, soaking up nutrients from the water or absorbing stuff through its skin. It was tricky to identify because most fossils came from high-pressure rock, where heat had destroyed all the delicate organic stuff scientists needed to study. To get to the good fossils, researchers had to rappel down 300-foot cliffs, dig out huge blocks of sandstone, throw them down, wash them, and then repeat the process. And inside one of those sandstone slabs was the fossil that changed everything. That helped finally confirm that Dickinsonia was an animal, which proves that complex animal life existed before the Cambrian diversification, where tons of new animals with bones, eyes, and limbs suddenly appeared. Scientists think the spot where they found these fossils might hold more clues about ancient life. For a long time, scientists had no clue what other group of ancient life forms, slime molds, were. These weird jelly-like blobs that pulse and ooze on rotten logs and forest floors aren't fungi like mushrooms, though people thought they were for years. It turns out they're more like amoebas, squishy, single-celled organisms that can move around. There are over 900 species of slime molds all over the world. You'll find them in soil, leaf litter, and especially on decaying wood. Scientists found them trapped in amber from 100 million years ago, and it looks just like modern slime molds. Scientists still know very little about how slime molds interact with other species, what role they play in ecosystems, or how they think without a brain, nerves, or a control center. But somehow, they can make decisions and adapt to their surroundings. It makes them a lot like social insects, like ants or bees, where no single bug is in charge, but the colony still works together as a smart group. Even without brains, scientists have trained slime molds to solve mazes just by responding to chemicals and learning from their environment. One way these organisms learn is through a process called habituation. It's sort of like how you get used to cold water after jumping in a lake, or stop noticing an annoying buzzing noise after a few minutes. That's your brain helping you tune out something harmless. Some slime molds can do this too. If they get in nasty conditions, like salty, dry, acidic environments or chemicals, they'll avoid them at first. But if there's food on the other side, they'll eventually get used to it and push their way through. And if you let slime mold go dormant and wake up a year later, it still remembers how to deal with salt. They even seem to be able to decide where to go based on where they found food in the past. With more and more unknown species discoveries, scientists can paint a better picture of Earth's biological past.
Whoa! It's a huge flying island right above your head. In the era of AI, you may think it's nothing but a neural network video, but let me tell you that first, it's very much real. 2, if you want, you can as well visit it. It may even hold the key to the El Dorado secret. This place is called Rorima, and it's actually not an island at all. It's a mountain. Due to a number of factors, we get this vision of an island floating somewhere above us. But it's all about the flat top this mountain has. There's no standard peak, so it looks flat, and the thick clouds get blended into the skies, thus creating this optical illusion. Despite the advancements in satellite technology and affordable air travel, there are still few places on Earth that feel truly uncharted. Like Mount Rorima is one of them. It's been around for almost 2 billion years, and it's one of the oldest formations on our planet. For comparison, dinosaurs appeared somewhere around 240 million years ago. Some scientists believe that this area used to be a part of the supercontinent called Gondwanaland. And back then, it wasn't yet a mountain. When the supercontinent split apart, the erosion created this magnificent tabletop mountain. But what's interesting about this place is not the age, but the fact that it still looks prehistoric. It's almost untouched. The reason for that is late exploration of this part of South America. By the way, we still discover new flora and fauna species living there every year. For a mountain, it's relatively short, only 9,220 feet. There are cities located at a higher pitch above sea level, say La Paz in Bolivia, whose elevation is 11,940 feet. So people could be living in the area of Mount Rorima too, despite its hard-to-get location. But there's a twist to it. The Pemon people are the original inhabitants of this region, and they have an incredibly rich tradition of myths. For instance, their mythology features deities that live on the Tepui, which are flat-topped mountains found in the grasslands. These mountains are considered sacred and are off-limits to the living since they're believed to be the dwelling places of ancestor spirits known as Mawari. So, there are traditions that restrict living in this area, but still, some sources claim that local communities do dwell there. But Obviously, modern problems lie not only in the spirits, but in very much limited job opportunities there. However, guided tours are actually available. So what will you see if you ever dare to visit this place? At the base of the mountain lies an evergreen rainforest featuring trees that range in height from 82 to 150 feet, with some specimens reaching up to 200 feet. Some of them are endemic for sure, meaning that it's the only place in the world where you can find them. Like, you can find orchids as large as a medium-sized tree. It's not a surprise because due to the remoteness of this place, species here may have followed a completely different evolutionary trail, unlike most of the flora and fauna on our planet. Next, you have all the chances to stumble upon a waterfall at the base of Rorima that's been flowing for millions of years. Fun fact, there are no rivers on Rorima summit, but the rainfall seeping through the porous rocks create this incredible view. All combined together make it look like some lost world, right? By the way, Sir Arthur Conan Doyle was inspired by Tepui, these tabletop mountains, when he was writing his The Lost World novel. Yep, it's not only Sherlock he was famous for. Among these natural wonders, Rorima stands out as the most accessible Tepui. There are more similar formations, but they're way less trek-friendly. Yeah, amongst other mountains, Rorima may be the easiest to get to, but still, it is very hard to get there, even taking into account all the modern technologies. So, how did the discovery happen? Hard to say for sure, but there is a theory backed up by official records. Back in the 16th century, here was this Sir Walter Raleigh. Look at his fancy collar and mustache. He was one of the most important people during the Elizabethan period. In 1594, he got to know about a great golden city near the Caroni River. That idea stuck in his mind. Maybe it was something like a get-rich-quick scheme for him. Anyways, 1 year later, he went to explore what is now Guyana and eastern Venezuela, and he described precisely Mount Rorima. On March 22, 1595, an English fleet led by Walter Raleigh showed up off the coast of Trinidad. Raleigh tried to make nice with the Spanish settlers there by trading and even inviting them aboard his ships for some entertainment. After a few drinks, the Spaniards opened up about a person having some particular activities in Guyana, sharing insights about the land's geography and the treasures they believed were hidden inland. Fast forward to April 7th, Raleigh pulled off a surprise attack on the town of San Jose and managed to capture this very person. After squeezing him for information, Raleigh declared his own plan to head into Guyana on a quest for the legendary Golden City. Since his ships couldn't navigate the narrow channels of the Orinoco Delta, Raleigh had his carpenters modify one of them, likely a galleass, to only draw 5 feet of water. This ship could carry 60 men, while another 40 were split among smaller boats. Progress was slow as they navigated through the delta, getting lost in what Raleigh described as a labyrinth of rivers. Eventually, they made their way to the Caño Manamo, and then into the main Orinoco River. A bit further upstream, where the Orinoco meets the Caroni, Raleigh encountered a native chief named Topiawari, and they hit it off. Topiawari revealed that his people had been pushed out of inland Guyana by a fierce tribe from the west. This fed into the prevailing belief, shared by both the Spanish and Raleigh, that El Dorado was home to runaway Incas from Peru. Topiawari also mentioned that the invading tribe was rich in gold, claiming that their nearest town, just a 4-day trek south, was the source of gold plates that were being traded far and wide. But he hinted that even finer treasures lay deeper in the land. Raleigh then made his way to the mouth of the Caroni, but strong currents halted any further progress. He sent out 2 scouting groups on land, while he led a third one. They unearthed a few shiny stones that they eagerly dug out of the ground, but most turned out to be worthless. They learned that a massive lake about 40 miles wide lay at the head of the Caroni, filled with alluvial gold. However, With no way to move forward and the Orinoco's waters rising, Raleigh had to call off the expedition, hoping to come back when conditions were better. It wasn't until 1616, over 20 years later, that Raleigh got the go-ahead from James I for a second try in Guyana. He assured the king he could retrieve a lot of gold from a mine near the Caroni that he had heard about on his earlier trip. James specifically ordered him not to clash with the Spanish, who were still controlling the Orinoco area. When Raleigh arrived in South America, he stayed on the ship while sending Lawrence Kemmys and a team to look for the mine. For reasons that remain unclear, Kemmys ended up attacking and capturing the Spanish town of Santo Tomé, resulting in the demise of Raleigh's son Wat during the skirmish. Unable to find the mine, the crew returned to the ship, and facing Raleigh's anger, Kemmys took his own life. Back in England, Raleigh was put on trial for allegedly lying about the mine and trying to provoke a conflict with Spain, which ultimately led to his execution. Or maybe those were the Maori spirits who didn't appreciate the intrusion. Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank one bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this. A massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes. and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of two completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the two regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So, while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades. For decades, time travel has been dismissed as impossible. But this physicist just cracked the code using quantum mechanics. He's trying to prove that time loops might actually exist without breaking reality. So could this be the first real step toward building a time machine? In everyday life, we're used to time moving forward in a straight line. It goes from the past to the present to the future. That's how people saw it before Einstein, because that's how it feels to us. But when Einstein showed up, he told a very different story. He showed that both space and time are woven together like some flexible fabric into one thing called space-time. Space itself can bend and twist, and time does the same with it. The fabric of space-time bends and gets curvy when we place heavy objects in it, like planets, stars, or black holes. The heavier the object, the more it will get stretched and bent, slowing down time around it. Movies like Interstellar showed it pretty well, even though the characters only spend a few hours on the planet. When they return to the spaceship, 23 years have passed for the astronaut waiting there. Why? Because the black hole's extreme gravity warps this fabric of space-time itself, and the closer you are to it, the slower things go for you. Sounds insane, but that's how our universe works. And that's not just black holes. All massive objects, like the sun, for example, bend the fabric of space-time around them. This is also why planets orbit in curves. All this gave physicists a pause. If we can bend space-time, can we bend it to such a way that we'll make a loop out of it? It would be like going on a journey that bends back on itself, meaning that if you followed it, it could return to the past and experience the same moments again. That would be pretty insane. Imagine that you walk down a hallway expecting to exit through the door at the end, but instead of a door, you find yourself standing right back where you started, walking into your past. But just imagine how hard something like that would be to pull off. Yes, heavy objects can stretch and twist space-time, but even those massive things still don't loop time. They just slow it down very strongly. It's hypothetically possible, but it would require super extreme conditions. For example, if the black hole gets a little extra boost, spinning, it could theoretically bend space-time around it into a loop. There are also some wacky ideas, like exotic matter and wormholes, but they're all speculative. But let's assume that there is a way to make a CTC. Creating it isn't our only problem. This is where the paradoxes begin. If a time loop could exist, wouldn't it create contradictions? The grandfather paradox is just one example. If you follow a big loop like that and accidentally prevent your grandfather from meeting your grandmother, you'll make it mean that one of your parents is never born, and you weren't born either. So how could you travel back in time in the first place? Or what happens to you after that? There are other ideas like that, like destroying your time machine before you use it, or giving William Shakespeare his own plays. There are infinite possible paradoxes. All this is happening because of entropy. It's one of the main laws of physics, this idea that chaos in the universe always increases. Things start as something normal and structured, but eventually they break apart, becoming weird and chaotic, and can never go back. Ice melts but never refreezes into its original shape on its own. Our bodies age instead of getting younger. We remember the past, but not the future. All these are examples of entropy. So, like, if time travel were possible, how would entropy behave? Would a broken glass fix itself? People would grow younger, and people would lose their memories? That's exactly how paradoxes like grandfather's paradox are born. Well, this is where the recent theory changes everything. The physicist Lorenzo Gavasino has a cool idea to explain this issue. He tackled quantum mumbo-jumbo, working with something called quantum fluctuations. See, the universe is never completely still. Even in empty space, at the tiniest level possible, there are constant random changes in energy. These are those quantum fluctuations. They're like tiny, unpredictable jitters that pop in and out of existence. Yeah, our universe is just weird like that. It's like a lake. On a normal scale, it looks smooth, but if you zoom in super close, you'll see tiny, unpredictable ripples forming and disappearing all the time. Our universe is the same with quantum fluctuations. These fluctuations happen everywhere, and they become really important when dealing with stuff like black holes and time loops. Now, back to the time loops. Gavasino says that in a time loop, quantum fluctuations mess with entropy in a strange way. Ideally, the chaos should increase. As usual, we're getting older, our spacesuit is getting weary, broken things don't fix themselves, and so on. But it seems like instead of always increasing, chaos in a time loop can randomly decrease. This means things that should be irreversible, like aging or breaking something, could actually reverse themselves. So yep, if you try doing something wild during time travel, it won't really work. If you try to prevent your grandpa from becoming your grandpa, the universe could reverse that change, making it like it never happened. If you travel to the past, your memories could vanish, meaning you wouldn't remember the future you came from. And if you try to break causality, the universe might just remove the contradiction. Time would always find a way to correct itself, preventing paradoxes. Scientists actually suspected this for a while now. Many of them have believed that if time travel were possible, the universe would somehow prevent weird paradoxes. Basically, it would make sure that everything that happens must be logically consistent with itself. Well, Gavasino's work basically gave a mathematical proof of that using quantum mechanics. Of course, there was another wild theory. The one with multiple universes. You definitely saw this in the movies. It says that when we travel back in time and change something, we simply create a new timeline. The old one remains, but this one would go a completely different way. But this idea is more about cool sci-fi than actual math and physics. But does that mean that time travel actually exists? Well, not right now. Even if time loops could exist in theory, that doesn't mean they actually do exist in real life. Stephen Hawking, for example, thought that these time loops are impossible. He said that the universe works in such a way that it would simply prevent time loops from forming. He even organized his famous time traveler party. Unfortunately, no one showed up. But many physicists still believe time travel is impossible, at least on a macroscopic scale. They even kind of managed to do that. For example, teams from Oxford and Vienna wanted to see if they can reverse one single electron back in time, and they managed to do that inside of a quantum computer, though the effect was tiny, only a fraction of a second. Recreating that normally would be absolutely insane. If we wanted to see something like this naturally, we would have to observe 10 billion electrons per second for the entire age of the universe. And even then, we'd only see it once. The more particles they tried to rewind, the more errors appeared. With one tiny electron, it worked well, but when they got to 3, accuracy dropped in half. But even if we never find a way to travel through time, understanding all these things could still help us a lot. It would help us study black holes, the early universe, and even quantum technology. So, while time machines are still science fiction, this research is pushing us closer to understanding our universe. Antarctica wasn't always a frozen wasteland. A long time ago, it was full of life, and 56 million years ago, something terrifying stalked its jungles. A giant, flesh-eating bird. It was around 6 feet tall and weighed as much as a lion. For millions of years, nothing could challenge it, so why did it disappear? And could there be even bigger predators still hidden beneath the ice? Paleontologists found 2 massive claw bones in Antarctica, sharp, curved, and powerful, belonging to this bird. They were dug up from the Epresian-aged rocks of Seymour Island, which means they're around 40 to 50 million years old. Their shape left no doubt. These were the so-called terror birds. Their scientific name is Forus raceti, some of the most fearsome predators to ever walk the Earth. They were flightless and didn't even need wings. Instead, they could sprint at breakneck speeds, like ostriches from a nightmare. For millions of years, these birds ruled South America. But now, for the first time, their presence has been confirmed in Antarctica. No surprise here. Back then, South America and Antarctica were still connected, allowing animals to easily commute between continents. So these birds probably migrated south to adapt to life on Antarctica's prehistoric landmass. It didn't just survive here, it thrived. But at some point, this nightmare of an animal vanished. Why? Most likely because of the temperature changes. Antarctica was cooling, slowly turning into the frozen wasteland we know today. Its prey may have declined, leaving the predator without enough food. Eventually, it disappeared, leaving no descendants behind. Researchers hope that they'll find a complete skeleton eventually. They're also wondering where there might be even bigger species waiting to be discovered. Perhaps these birds evolved into a completely new Antarctic lineage. But for now, all we have are 2 giant, creepy claws. People often think that there are almost no animals or plants in Antarctica. But that's not true at all. Penguins waddle around, and forget the cute tiny ones. Antarctica used to have 6-foot-tall monsters. The emperor penguins are the largest penguin species alive today. They can dive over 1,800 feet deep and hold their breath for over 20 minutes. There were giant ancient penguins around 38 million years ago. They were the size of humans. Fossils show they had long, sharp beaks, making them terrifying hunters of fish and squid. The fish there are also absolutely fascinating. Forget giant squids. Colossal squids are nightmares even bigger. Some reach over 40 feet long with massive, super sharp beaks and eyes the size of dinner plates. Finally, orcas, the apex predators of the Antarctic Ocean. They hunt in packs, working together like a wolf pack of the sea to take down seals, fish, and even massive whales. There are even tiny plants like moss and algae. Antarctic hairgrass and pearlwort. They somehow survive against all odds. There are many other myths going on about Antarctica. For example, some people think that when icebergs break off from glaciers, they immediately start drifting straight into the open ocean until they melt. But the reality is way more chaotic. First, when an iceberg breaks off from a glacier or ice shelf, it has to deal with underwater obstacles. It can stay stuck on the seafloor for decades without moving. Then they get caught in powerful whirlpools and spin in place for months. One iceberg, a 23A, spent nearly 40 years frozen in place before finally breaking free, only to get caught in a swirling ocean vortex for another 8 months. After that, their paths are influenced by ocean currents, tides, winds, and even underwater topography. They don't just float freely, their movements are full of literal, unexpected twists. And speaking of glaciers, Another strange rumor is that some humans can't travel more than 311 miles inland in Antarctica because of an impassable ice wall, freezing jet fuel, deadly winds, and no oxygen. But this is completely false. Antarctica has been explored by planes, vehicles, and even scientists on foot. There's an entire research station sitting at the South Pole. People live there all year long. The ice wall is real, a massive ice cliff rising above the ocean. But that isn't some secret barrier, it's an ice shelf. These are thick slabs of ice that form when glaciers slowly flow off the land and spread over the ocean. Almost 3/4 of Antarctica's coastline is made up of them, but they don't form some giant ring around the world. Antarctica is one of the most extreme places on Earth, but we've conquered its challenges and we keep learning more about it every year. That's why every year, millions of dollars are poured into keeping research stations running, protecting wildlife, and making sure the people who live there have everything they need. But where does all this money go? Well, Antarctica stations are basically small cities. There's electricity, heating, water purification, food storage, and medical facilities. The biggest station, McMurdo, is basically a town with over 1,000 people in summer. It has everything from a fire station to a gym. The South Pole Station is super deep inland, so it's one of the hardest places to supply. Getting food and fuel there requires airplanes flying thousands of miles in extreme cold. But the internet loves a good mystery. When Google Maps revealed what looked like a massive doorway in Antarctica, conspiracy theorists went wild. People joked about everything from Bigfoot's vacation home to a secret base, or even a Star Trek spaceship hangar hidden in the ice. But there's a way simpler and less exciting explanation. It's actually a grounded iceberg, a chunk of ice that got stuck in shallow water and is now slowly melting. As ice moves across the landscape, it flows around bumps and obstacles, creating odd shapes. The process of melting, breaking apart, and refreezing can carve ice into unexpected forms. Antarctica also has incredibly strong downward-blowing winds that sculpt ice into dramatic formations over time. No secret doorway, unfortunately. And speaking of doors, for years, Ushuaia, Argentina, has been called the gateway to Antarctica, the last stop before the icy continent, the place where expeditions begin. But there's another option. Punta Arenas, Chile. Let's compare them. Ushuaia is closer to Antarctica. It's the top departure point for tourists going on cruises. But no regular flights to Antarctica. No major scientific bases operating from here. It's basically controlled by the military, which refuses to allow private flights, only commercially operated ships. Yes, Punta Arenas is further from Antarctica, but 22 countries and global organizations use it as their main base. There are regular flights to Antarctica happening there every year. Private airlines can actually operate here, making it the real air connection to Antarctica. Ushuaia may have the best location physically, but Punta Arenas actually runs the show. Argentina made a huge error in picking its Antarctic airbase. Instead of setting up a simple, accessible base at sea level, they built Marambio Base, very high on rough terrain, completely impossible to reach by land. Everything has to be flown in by helicopter, making operations slow, expensive, and frustrating. For 50 years, Argentina stubbornly stuck to this bad decision, while Chile set up efficient, well-planned bases that the world now uses. If things don't change, Ushuaia will be nothing more than a tourist stop. But what's terrifying is that Antarctica seems to be returning to its past. It's supposed to be the coldest place on Earth, but something shocking happened just recently. For the first time in recorded history, temperatures in Antarctica broke 68 degrees Fahrenheit. This continent is buried under miles of ice. Usually, temperatures there can drop to minus 112 degrees. But in the winter of 2020, scientists recorded an insane 69 degrees on Seymour Island, hotter than many places in Europe at that time. Scientists believe there are several reasons for that. First, there are changes in the way heat moves around the planet's waters. Second, melting permafrost due to the planet warming. It looks like the climate is changing faster than expected. Scientists think there might be a huge onion chilling somewhere out there in space. Not an actual one, but it's something even crazier. These are stars stacked inside each other, layer upon layer. These fascinating objects, called Gravis stars, could even be cousins of black holes. But most importantly, they might hold the key to understanding some of the most mysterious puzzles in the universe, dark energy, and even other dimensions. Let's start with gravity. Over a century ago, Albert Einstein helped us understand how gravity works. Turns out, it's not just something that pulls things on Earth and makes apples fall on Newton's head. It's much wilder. It's about warping the very fabric of existence itself. Let's say you toss a heavy ball, like a bowling ball, onto the middle of your bed. What happens to the sheets? They dip, don't they? They stretch and sag around the ball. Now, if you roll a smaller ball, like a marble, across the bed, it doesn't move in a straight line anymore. Instead, it starts circling the heavy ball, rolling closer and closer as if the heavy ball is pulling it in. That's gravity. But instead of bed sheets, we're talking about the fabric of space and time itself, or space-time for short. Heavy objects like planets and stars make dents in space-time, and moons, planets, or even light move along these dents. Gravity is the curve that tells them where to go. In that case, you can guess that black holes are like the ultimate heavy balls. The heaviest, in fact. The gravity is so strong, it shrinks them, making them smaller and smaller. So tiny, they could fit in the palm of your hand, but with the mass of several suns. Some of them are like holding over 40 billion solar masses in your palm. It's ridiculous, but they basically create a bottomless pit in space-time with insane gravity. This area around them, called the event horizon, is the most horrifying thing ever. It's a point of no return. Once something gets there, it can never escape being eaten. When something falls past the event horizon, it can't climb back out, not even light. Which is why they seem like, well, black holes. But Gravis stars, they're something much weirder. Just like black holes, they're probably very compact. But instead of being tiny pits of endless gravity, they might have something wild at their core: dark energy. This is one of the universe's biggest mysteries. Dark energy, this invisible, mysterious something that seems to be pushing the universe apart faster and faster. It's like a polar opposite of gravity. While gravity tries to pull things together to slow down the expansion of the universe, dark energy is trying its hardest to make our world even bigger. Luckily, dark energy has been winning so far. Otherwise, we'd all be in some deep pit. But if we can explain the gravity with balls, then what exactly is dark energy? A force, an energy field. Something else? We have no idea. Scientists have seen its effects. They know that it's incredibly spread out everywhere, but they can't tell you what that thing even is. But if it's trapped inside of Gravis stars, maybe we'll finally discover the truth. This name stands for gravitational condensate stars. Gravis stars were dreamed up by two physics professors, Paul Mazur and Emil Matola, in 2006. They tried to think, what else besides black holes could happen when a massive star collapses on itself? That's how they created this alternative. Think of it this way. Gravity pulls everything inward, making super heavy objects like stars shrink in size. The more the star shrinks, the denser it gets, and its gravity grows stronger. After some point, it can cross a critical threshold and become a black hole. But what if there was dark energy inside to counteract this? At the core of a Gravis star, there could be a region filled with false vacuum or dark energy. This energy would push outward, fighting the gravity. It's like the unstoppable force meets an immovable object. Thanks to this, the star core doesn't collapse into a black hole. Sounds wacky. We don't know what dark energy even is, so how can it fill up anything? But luckily, even if scientists can't fully explain dark energy, they still have strong mathematical models to check how it works in our universe. So, they decided to test this theory. Here's where things get even weirder. The new theory says that Gravis stars might not be simple lone objects. Instead, they could be stacked one inside another. Each one is like a layer with its own dark energy bubble inside, surrounded by a thin skin of matter. The outermost shell would hold a smaller Gravis star inside it, and that one could hold an even smaller one, and so on. It's like a series of balloons, one inside the other. The air pressure in each one of them is stable, evenly spread out. Thanks to that, none of them deflate. They coexist without one popping or collapsing the others. In the case of Gravis stars, the air is dark energy, and the rubber is the shell of matter surrounding it. It sounds crazy, but it actually makes this whole idea more realistic. A single Gravis star might have a very thin shell of matter, but the thicker they are, the more likely it is to exist in a stable way. And finally, the coolest part about them is that they could explain one of the biggest mysteries of our world: how universes are born. When a star collapses into a Gravis star, the matter could theoretically implode through the center and create a new dimension. This would connect these objects to the Big Bang itself. Some scientists even speculate that dark energy could be the energy exchanged between our universe and a child universe that's created from a Gravis star. Of course, these are all just speculations for now. But where are all those Gravis stars? And how do we test this? Well, physicists aren't sure either. They're more of a what-if thing than an actual object that they discovered. Those two professors just tried to imagine what would happen if gravity and dark energy worked together like this. For now, the LIGO, a big observatory which detects ripples in spacetime, hasn't found clear evidence of Gravis stars. Another problem is that Gravis stars would only be stable in specific cases. For example, if they spin too fast or their shell will be too thick, they might start to wobble or break apart eventually, though it could actually take billions of years. Plus, even if we don't see them right now, remember that this is exactly what happened to the black holes themselves. When Einstein published his groundbreaking theory of general relativity, another scientist, Carl Schwarzschild, took his equations and found a solution to them. And that's when he realized, if gravity becomes incredibly strong, the light wouldn't be able to escape, and this could create a sort of hole in space. Einstein even thought that this sounds too weird to be true. It took many years for us to confirm black holes' existence, and we finally took a photo of one just a couple of years ago. You might remember that blurry picture that blew up online? It was Sagittarius A star, an incredible supermassive black hole in the center of our galaxy, Milky Way. So that's why scientists approach Gravis stars so seriously. And since all the math checked out, which means that these objects are actually possible in real life. Now, we just need to see if they're somewhere out there. What's interesting is that they'd probably look like regular black holes. They could emit high-energy radiation as they consume matter. They might even produce something called Hawking radiation, a type of energy that escapes from black holes. In other words, it would be nearly impossible to tell the difference. But Gravis stars have a small trick up their sleeve. If their shell is transparent to light, they might bend light in a slightly different way than black holes do. So maybe if they check the way light is bent around the mysterious object, they could spot the difference. And even if it turns out that Gravis stars don't exist in our reality, they're still valuable to science. They still taught us more about gravity, black holes, and the limits of relativity.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.